how the NUCCA tool set and related functions operate in the TigerView world. So over here are loaded the 3 images that I uploaded, and it's the typical upper cervical series of a lateral, nasium, and vertex. And whichever one you click on will appear on the main screen. Now, up on top here, I have the NUCCA tools, and I'll explain these. CR is for cranial rotation. That's done on the nasium to ascertain whether or not the X-ray was taken with rotation within limits in terms of patient positioning. Then we have the CSL, stands for central skull line. This instrument is the cephalometer, but it also works in the vertex to construct the vertex skull line. The APL function is the atlas plane line. On the nasium view, it does the same as we used in the analog, but this is also the same function to draw the atlas plane line on the vertex. The atlas check line is used as the atlas check line indicates, and it'll read the angle that it makes with the central skull line. But you can also use it to construct your own vertex square on the vertex to check for other points. The IML is the intermastoid line. It acts just like the atlas check line, except that you place this line over the tips of the mastoids to check the consistency of your central skull line on your pre and post analysis. And if you do multiple pre's, this is another, or post, this is another way to verify where that, if any discrepancy may be. The BC stands for body center, but this also is the cervical line. So what this does is it finds the center of C2 on top and the center of C7 or T1 at the bottom of the cervical spine and constructs the cervical line and reads the angle. DC stands for condylar circle. You mark 4 points going left to right. So the outer left point, the inner left point, the inner right point, the outer right point. Axial circle is, well, you only need to place the inner points because the outer points, the software program knows to use the same ones used for body center. And you can manipulate these to make the circle fit correctly. There's no instrument for this. Plane line function is one of the 4 factors that we calculate. Vertical axis line is the other line that we draw from C7 or T1 to the top of the film, and it establishes the vertical plane. Then the NT stands for N tracker, so when you click on this, this gives you a dialog box that will automatically populate with the numbers as you go through the analysis. This is the vertex tracker. It does the same thing for the vertex and allows you to select whether you're dealing with a right or left laterality. And then SPC is spinous process center. This is a function for the vertex where you find the center of the dens and then mark the lamina pedicle junctions, and it tells you where the spinous center is off the vertex view for the transverse plane. Sorry about that. And then RM stands for remove or reset, so it'll remove all of your annotations. Now, over on the left-hand side, we've got different tools. So, for example, when you click on menu here, you get this here, and then when you click on the configure button, you get all the functions that are available in this program to appear. And once again, I don't know all of them, but the ones that I use, and by the way, you can click and drag any of these into the left box here to have them permanently reside there. So that all of these, for example, this is to undo the last function, and it'll cycle backwards through it, or you can redo, so you can go back forward. The buttons underneath, this one is to save the annotation. So after you've done an analysis, you can actually hit this button, and it'll separately save the analysis for that image, and then you can recall it, at any point by hitting the load anno button. The one below is the full screen. What that does is that simply gets rid of the tabs on top, gives you a slightly larger view. And then this is the pan button. And then this is the contrast button. So when you select that, you then move over the image and while holding the left button, move up, down, right, or left, and it'll change the look of your X-ray. Then back here on the bottom, the millimeter, you can select either millimeters or inches. It'll read either way. And then calibrate XY. If you import an image, or even if you want to calibrate to make sure that the image is sized correctly, you can select calibrate, and it'll you mark specific points that you know the size of. For example, the head clamp. You either have a 2 or 3 inch head clamp pad, and then you simply mark its length on this, and then it'll calibrate the image to that size. And then this is simply a line drawing. This is to put or remove annotations. So it doesn't erase them. It just simply removes them from view until you click it again and they reappear. Now, and you can put any one of these in the same box here as you desire. It's totally customizable in that regard. Now, over here then are the same NUCCA tools that appeared earlier. Then to the right of it is this row. And what that button allows you to do is to click and drag the analysis tools for the NUCCA analysis into a separate column that you can add whatever order you want and however many functions you like. And what that does then is establishes this macro button. So that, let's say you analyze your nasium the same way every time. And NUCCA recommends that you do the full analysis on every nasium. So when you click the macro button, it'll go into this order automatically and finish the entire column as you program it. And then what happens is that once it runs the program, you don't have to go back and select each tool individually. I'll show you in a minute how that works. It'll automatically cycle to the next item as you go through this. So it gives you a little reminder of what to do next, but you don't have to go back and select the button. So it's a real convenient feature, saves on moving the mouse around so your mouse will last longer. So once you've made all those selections, then you click on configure, and you're back in the regular program. So we'll bring up the NUCCA tools here. This is with a team viewer, so it's a little bit slow to react to the big changes. There we go. So now, for example, to draw the Atlas plane line. Oh, by the way, to pan the image, you can select it, although you have to first shrink the image. Yeah. So the wheel will increase or decrease the size of the image, and then when you select pan, it allows you to move the image around. So once you've got that, we can go back to the NUCCA tools, and to find the Atlas plane line, you can simply use the Atlas plane line function. And for example, you can select the point here, and then you can select another point here, and that'll give you those 2 points and where it projects outward. The smaller circle in the middle is the midpoint. So this would be your S line, and you can shift these at any point to any position that you want. Like if you wanted to change the S line, all the points are always movable, and then allows you to select the S line. And if you want to write that down, you can go into the text and select the text button. Now, so once again, we can undo that. There. And so there's your Atlas plane lines function. So then, let's say we go to the nasium. We select nasium, and once again, let's go to full screen. So when you select full screen, it gets rid of the tabs. Now, in our environment, what we have here are the 4 buttons, 4 arrows. These correspond to the 4 arrows on the keyboard. So any function that you select, you can then highlight a movable point on it, and then click these buttons, or select the keyboard buttons to move that function up, down, left, or right, or whatever that function does. So for example, I'm not going to go through the macro right now. We'll bring up the tools here. So let's say we want to check this image for cranial rotation. So first we can enlarge the image a little bit, and then we select the function. And oh, by the way, you go over here to line picker, and you have a palette of colors that you can select. So you can choose whatever color you want, depending on the density. Red, yellow, green, black, or white. For those of you who are switching from analog and you like the black lines of a pencil, you can do your analysis in black. But let's stay with red for this demo. So when we select cranial rotation button, what you do is you look for those points that we click on here, and you go to the outside and click one point there, and you find the like point on the other side and go to the outside and click. And it constructs a line that already tells you the millimeters, and then you take the inner point and move it to the point where you think that intersection will give you the truest representation. So they're selecting where the skull comes in. Like, I'm not going to pick the mastoid on this one, rather than following the temporal bone here. So that gives me a 14.89 on one side and a 13.27 on the other. Now, you can keep that measurement up, or if you find it visually clutters, once you've established that, you can remove it by going here. To remove annotations, the remove reset. So when you click that button, it goes away. So let's say now we've established that we've got the correct cranial rotation. We want to do the skull division. So we'll bring up the NUCCA tool set and we'll select the central skull line function. And so this then creates a cephalometer. The cephalometer has a couple of functions. It has a pivot that you can move anywhere you want. So, for example, we'll put it up near the squamosal suture. It's got a rotate button that once you select that, you can then either use the keys on the keyboard or here. Once you select it, whichever way you move the rotate button, it will pivot. So if you have right head rotation, you can select this and move this function to the right, and it'll pivot around the pivot or left. And anywhere where you put the pivot becomes the pivot. So once you've established that one function, you can then also move the template. So this move template will only move the template up and down along its center line. You can't move it to the right or left, and it won't rotate. So this is how you can check multiple points. Then if you want to move the whole template around, you select the move template, and then this one allows you full range of motion, although it won't give you the rotation. The rotation I just explained. So let's say we line this up this way, and this is where this comes in handy to use these. So let's say I want to match the skull here and here. Once I've selected the move button, I can simply have the arrow move the instruments very, very incrementally until you like it. Now, let's say you want to get the skull to fit better. Then you go to the adjust all function. And once you have the adjust all, you can use the buttons to, if you move the up button, it'll make the cephalometer grow incrementally. You can see how it's getting larger. You can also make it smaller. And so what I would like to do is get it to fit exactly over. There's a little lag period, so I'm sorry about that. It's because we're doing a team viewer session. It actually, in real life, works much faster. And so now we can move the instrument over a little bit. So now, never mind that it's right at the squamosal sutures, but what I'm trying to point out here is that you can change the shape of the cephalometer to accommodate. Now, once you select the adjust all, you can make the cephalometer smaller or bigger by selecting the up or down arrow. But the right and left arrow will move the grid inside as well. So you can see now I'm pressing the left arrow, and you can see that the shape of the cephalometer is changing. Or you can also select the button and move it up or down, in or out. And so this allows you to have an infinitely adjustable cephalometer. So virtually no skull will not fit. It's a really easy way to do this. So then the actual analysis remains the same, although with this program, I didn't program it to have the points that you select, because in the digital world, that restriction about keeping the cephalometer on the center line is programmed in. So you don't have to have little points that you select here. What you do is you move the cephalometer, the template, up or down, or you change its shape by choosing the adjust all, and you find what you want to do. And if you need to rotate, then you select rotate and make the cephalometer rotate about whichever pivot point you select. So let's say we'll select this one. We're going to move the instrument to the right a little bit to be more symmetrical. We can adjust the instrument downward. So now you can see that this point here and this point here is consistent. We check the next point up here and here. And we can also check multiple points in between by bringing the instrument down and then selecting adjust all and making the instrument have an intersection that matches here and here. And if that doesn't match, then we can rotate it a little bit. And you can check multiple points. You can change your pivot anywhere you want. But once you've got a skull division that you find is symmetrical for whichever section that you want to analyze, then you simply either select the central skull line button again and click it, and then it constructs a line. Now, right now, the line doesn't know where to end because we haven't drawn the atlas plane line. But, as a reference, once again, where that line goes through the marker under the glabella and all that, and there are other verifications later. So let's say we select the IML function, and just for fun, we'll do the non-analytical stuff in a different color. So we'll select IML, and you simply click at the tip of each mastoid, and it'll tell you exactly that's the L.33 degrees is your IML. And once again, you can select it and then use the arrow key to move it up or down. And as you do that, you'll see that the numbers are actively changing, and it'll reset to wherever you want. So there's your IML. Let's go back to red. And so now let's select our atlas plane line. But let's pan the image first so that we get it more on center. Enlarge it a bit. So now, let's bring the NUCCA toolset back up. To select APL, you simply find the attachment point of the inferior rim of the posterior arch of atlas, select it, and then find the opposite side and select it. And it constructs a line. It also tells you the midline. So here you can see where your central skull line intersects with the center of the atlas. And once again, it's a guide on the accuracy of your analysis. And so then here it also tells you that we've got a right laterality of 1.92 degrees with right head tilt of 0.62 degrees. Now that you don't have to worry about these numbers here because they'll also populate automatically in the N-tracker function, which I'm not going to bring up until we've done the full analysis. So now let's say that we want to select atlas checkline. Well, atlas checkline, once again, is not part of the analysis, so we'll switch back over to yellow just for fun, and we'll click you select the superior attachment points here and here, and it tells you that the points that I selected are slightly not parallel, so I've gone between 1.92 and 2.17, which is 0.2 of a degree apart. So, certainly not a large discrepancy. So we've got that select. Let's go back to red. And so now, let's say we're going to go to body center. So body center works just like any other program. You select the outer edge of the superior articulating surface of C2 on one side. You select the light point on the other side. And then you mark the center of the spinous of C2. And what the program does is the smaller circle on top is midpoint between your lateral points. And then the second small circle is midway between spinous center and body center. So it automatically constructs that for you. And you just go right on to the lower cervical, click the transverse process of T1 on either side, and then mark where the spinous is. And that constructs your lower angle. Once again, it does the same thing where the upper circle in the center is the center between the transverse process of T1. And then this is the spinous process of T1, and the circle small circle in the middle is the midpoint between, and it automatically splits both centers. So that it doesn't list the lower angle here or the cervical line, but it'll list it in the end tracker, and we'll get to that shortly. So that's the function for body center. So let's say now we'll go to the condylar and axial circles. So on those, let's say we'll select white. So when you select condylar circle, you start from the outside, you make 4 clicks. And it not only draws the arc and tells you that you've got a 3-inch condylar circle, but it also tells you where the center is and draws a radius. Now, to select the axial circle, what you do is you follow the superior articulating surface to the right where the periodontoid dips are, and you select those 2 points. And when it constructs that arc, whoops, hold on. When it constructs that arc, you now have to move it so that it'll go through all 4 points. The outer points are automatic. So now I've highlighted this one here. I'm going to press the down arrow until I get the white arc to go through the centers of both circles. And this is like getting the best fit. So we've got a 3 condylar, 9 axial circle. And all of these points are movable as well. So you can move this one up and down, you know, and you move that until you get what you know, you perceive to be the best fit. Then the plane line function will go to black for these. So the plane line function is just the way you would do it in the analog world. You select the intersection of the atlas plane line with the outer mandible limit of the jaw on the side opposite of laterality, and you click on that point, and it establishes that point there as well as a horizontal line. And then you make a second click at the atlas plane line on the side of laterality, and it tells you the vertical relationship between those two in inches or metric, depending on what you select, and that tells you that calculation. And then we'll establish the vertical axis line. We can go with green on that color. So when you select vertical axis line, you simply click here, and it establishes a vertical axis. All right, so that's the analysis on the nadium. Now, when we select the end tracker, a dialog box comes up here, and let's go through this. So it reads the atlas is right 1.92, and that's that measurement that we took off of here. And we've got right head tilt of 0.62. Our IML populates this box is left 0.22, and that, once again, as you change things here, they'll change here as well. Cervical line is the new way to describe the lower angle or angular rotation, is now right 1.71. It doesn't read it here, but it reads it here. And we've got left angular rotation of 3.02 degrees. So that means that we've got less translation of the cervical spine. Here's your body center measurement. Now, I don't convert these into condylar measurements. You can go with metric or you can go with inches. You know, the fact is that the way that the analysis is evolving, you know, the difference between whether you're talking about a condylar relationship of circumferential movement or you know, the same circumferential movement in inches, it's the same measurement, and you know that you either have to do torque or not, and how much, and it'll also let you know whether or not you need to adjust for body center displacement relative to center of atlas. So then here's your plane line measurement. Now these are all taken as straight measurements. I don't have the program do the calculations for you. It just gives you the straight numbers. So you know, this 0.09 of an inch in this case would add a half an inch to your height vector, so you know that that's 2/16. That's plane line. Your C over A ratio is a straight ratio. It doesn't round up, round down, so you can do that yourself. But you can see that if you were to take this 9.91 and round it up to a 10, you know, it's not going to change this ratio by more than a couple of hundredths of an inch. And then head tilt, it automatically will subtract head tilt from the height vector in terms of, because this is a basic type 2. Then the angles in this case, because the angular rotation is less than laterality, this is all programmed to give you the correct calculation here. And then the height vector is the sum of these four factors. And so there's your selection. Now, I also didn't program this to tell you what basic type it is for two reasons. One is I think that from a biomechanical point of view, the doctor needs to be cognizant of what is being analyzed, rather than just following numbers on a screen. And two, in some cases, like let's say you have a basic type 1 with a slight head tilt, 0.01 degrees of head tilt into the same frontal plane as laterality. Well, that would not make it a type 4 in anybody's book. And yet, how do you tell a program that at what point do you not count head tilt? And that opens up arguments and programming nightmares. So this part, you gotta know your biomechanics. You gotta figure it out. This is not a NUCCA for Dummies program. All right. So then let's go to the vertex. There we go. All right. So when you get to the vertex, once again, if you want to change the density, you can select the WL function. And so then when you move the arrow up or down, the cursor, you'll get, once again, the changes here are slow. All right. So let's say we want to keep it like this. So we'll go to the NUCCA toolset once again. So, once again, the order is not important, but let's go through, let's use red again. So, use the APL function to outline the transverse foramina. So you could select a point here. You could select a point here. And once again, Atlas Plano will also tell you where the center of the dens is. And in this case, it's not on center, but when you look at the atlantodental interspace on the left versus the right, you can see that is displaced, in fact. All right. So now, if you want to use Atlas F-line as your box, like the vertex square, you can select as many points as you want and construct, and then you can move these anywhere you want. And this tells you whether or not you're boxing in your Atlas symmetrically. All right, so you can use as many of those check lines as you like. Next, what we can do is go to the spinous process center. So for this one then, you mark the base of the dens on either side, and then you mark the lamina pedicle junction, and it constructs a triangle, which is sized correctly for the neural canal, and it tells you how far that is off of the center of the dens. So the next function will go to the central skull line. And this was a bit of a flight of fancy on my part. What I do is I use the cephalometer just out of efficiency's sake, because you can use it multiple ways. So what I do is I position the pivot over the center of the dens, and then initially, I select central skull line again, and it constructs a line, and I look like, do I endorse how that line looks, And so in this case, I would, because even though it's not going through the center of the glabella, you can see the nasal septum is slightly deviated to the left here, but the bulk of the central raphe, the cribriform plate, is parallel to the vertical axis. So I would keep this line. But if you don't like it, you can then use the function to highlight the rotate button. And you could rotate this, let's say, move this down just a little. You select the rotate button, and then you could rotate this. Let's say you like that move. Oh, now it's moving, all right. Or let's say we want to move it back a little bit, like that, and then you select central skull line again, and it constructs that line. Then when you go to end tracker, V-tracker, there we go. V-tracker, it lets you select the option, do we have left laterality or right? So we select right laterality, and in this case, we've got an anterior 0.18 degrees, and the spinous center is to the right inches. So there's the analysis. Now, if you want to save this analysis, you go over to this button here and select Save Analysis. And then you can toggle between having the listings up or not by going on that button. And there's your full analysis. Now, let's go back to the Nasium. And what I'm going to do now is remove all the annotation and show you how the macro works. So when we select macro, it automatically pops up the central skull line first. And so you analyze this. I'm not going to go through the full analysis here. I'm just going to show you, how this works. It's virtually the same tools, only now it's in a macro function. Then you hit enter, and it'll select the central skull line, and it'll automatically tell you the next thing you want to, you select is you do the IML, and I'm going to do this all in one color. You select that, then it tells you to draw the APL, and once again, you've got all the other tools available of making this thing grow, right? And then you go to Alice checkline. Then you go to body center, and so body center, once again, is the same function. You select outer points, the center, and transverse process, and center. Then it tells you to do a condylar circle next, so you've got 4 points here. An axial circle. Once again, until you go to the next function there. So let's